It's my great pleasure now to introduce the last but not the least speaker of today, coming from an early morning in California. Rustom, thanks for being here with us. Rustom is the CEO of Blue Robotics. You probably know this company. He has a background in mechanical engineering and software engineering. He was previously an engineer at Advanced Tactics until 2014 when he founded Blue Robotics through a Kickstarter funding initiative, as far as I remember. So, without further ado, please.
Yes, thanks, Fausto. So, just a moment here. I don't think I've presented in Microsoft Teams before, and it's going to make me adjust some security preferences here. Can you see my presentation? Fausto, you're muted.
Yes, it's not on full screen, but it's also okay if you can
okay,
it better. There's try present, see if it works. Yeah, perfect.
All right. All right. Thank you, everybody, for joining and for having me. It is early in the morning here, but I'm happy to be here, and I hope that the rest of this day has gone really well and been very productive for you all. When I've got this in full screen here, I can't actually see your hands or questions or comments. So I'll go through. Fausto, feel free to interrupt me if there's any questions or hands along the way. I'd be happy to answer. But I've left plenty of time at the end for questions as well. So I think compared to Eden here, I'm gonna step back a little bit further to kind of the beginning of the concept development phase and talk a little bit about our story as a company at Blue Robotics, and then just talk about some of the key elements that I think are really important if you have an idea or concept that you are trying to take and turn into a company or a business or a project in some fashion. All right, so I'm going to start with a little background on myself. My name is Rusty. I'm the founder and CEO of Blue Robotics. I've been doing that since 2014, and there's my email address if you're interested in reaching out to me after this. My company is Blue Robotics. We're in Torrance, California. That's just outside of Los Angeles. Right now we have 48 team members on our team. You can check out our website there. And the important part here is that we were founded in 2014, almost 7 years ago now, which is unbelievable, with a mission to provide low-cost, high-quality components to enable the future of marine robotics. And that mission statement there is important. I'm going to talk a little bit about the vision and mission behind your idea and concept today. So that's our core vision and mission and what we've tried to create over the past 7 years. So this all started from an idea back in 2013. I have a robotics background. I studied mechanical engineering and software, and then I worked at a startup company developing autonomous drones back in the 2010 to 2013 range. And near the end of that, around 2013, my company was not doing so well, and I was kind of getting bored. One of my friends who also had a robotics background and I decided that we wanted to do something fun. This was just a hobby project out of our living room. We wanted to do something cool that nobody had ever done before. And we thought, why not make a solar powered surfboard and send it from Los Angeles to Hawaii? Why not? We had both learned to surf a couple years before. We had an old surfboard that we could use. We had robotics backgrounds. It just seemed like a cool fit. Nobody had ever done this, and it seemed relatively simple. You've got a surfboard, push it off the coast here in Los Angeles. It's just got to go about 4,000 kilometers under solar power. Take 2 to 3 months, but eventually we'd have a good excuse to go to Hawaii and pick it up on a beautiful beach there. So we started working on this just for the fun of it, and as hobbyists, we found everything that we wanted pretty much. We found a GPS unit we could use, found computers and microcontrollers to control it. We found a satellite radio so that we could literally talk to it the entire time along that path. We found solar panels, compass, temperature and pH measurement sensors so that it would actually do something useful along the way. All the stuff was pretty easy, fit into a couple $1,000 budget. And then we got to the thrusters to propel it. And that's actually where we stumbled. That's not where we expected to stumble, but that was the problem. So we could not find thrusters. The only things on the market were industrial grade or military grade, thousands of dollars each, especially if they were going to last for several months in the ocean. I think we got quotes anywhere from $800 each to $3,000 each for a little thruster, little electric motor that could generate 5 pounds of thrust to push this thing across the ocean. And to us, working from a small budget, that was not going to work. But in searching for better solutions, we found a lot of people online who are looking for the same thing. We found students, hobbyists, people who are trying to start businesses, people on online forums. And so what we discovered is that there's clearly a need for underwater thrusters. We actually didn't come from the marine robotics industry, so we didn't know very much about it, but there was clearly a need here. And we kind of pivoted from this idea of making the solar-powered surfboard to maybe we can make thrusters to enable our project and to enable other people's projects. And so we did that. We filled a garage with tools, started building prototypes, and came up with a really cool design that you can see here. And so this is what we have now. This is the core. This is the core of our business. This is still a product that we're selling here 7 years later. We sold almost 60,000 of these thrusters since then. And this component here is a core building block for marine robotics. Almost any project is going to need some sort of propulsion, whether it's a surface vessel or an ROV or an AUV. So this is just a really fundamental need, and that's why we stumbled on that first, because people who are trying to pursue marine robotics projects were running into the same problem as us. They couldn't find thrusters. So we built one that was small, efficient, multi-purpose, well documented, and probably most importantly, about 10 times cheaper than anything else on the market. When we launched it, it was just $100. Now it's about $180. But that was completely game-changing for this market. And we actually did a crowdfunding campaign through Kickstarter in 2014. We raised $103,000, and we sold 600 thrusters to people around the world. And those backers of our Kickstarter campaign many of them have become very good, dedicated customers who still buy things today. But if anybody's thinking about doing crowdfunding, I have a lot of opinions about that. I'm not sure I would do it again. All right, so the Solar Surfer did in fact happen, but it did not make it to Hawaii. Here's a picture in 2014 of that old surfboard with solar panel, 2 of our prototype thrusters, and went about 50 miles in the ocean over a couple tests. But every time we ended up running into seaweed and getting caught up and had to go out and rescue it. And then eventually we were selling enough thrusters that we had to pay attention to that, so we just set this aside. And it's still sitting in our office in the museum today. So from there, we kind of developed the vision and mission for our business. We started to understand our market, and this is what that looks like. So I personally came from the aerial drone industry. I was building quadcopter type helicopters back in 2010, and I watched that industry grow. It was pretty wild to watch. There were a bunch of inputs that caused the aerial drone industry to grow from garage businesses to literally thousands of companies working on this in a short span of 5 or 10 years. There were lots of potential applications and benefits to drones. There were affordable core sensors and processing, cheap electronics. There was open source hardware, made it easy for people to get in and for new companies to get started. Open source software, which also made it easy for companies to get started. And then importantly here is there was an abundance of affordable drone components, which is because there was this remote controlled airplane industry that had existed for 30 years. They'd moved their manufacturing to China. So you can buy motors, propellers, airframes, landing gear, servos, all of these components, all the raw materials needed to build drones were available on day one of the drone boom taking off around 2010, which was really cool. It enabled that industry to move extremely fast. It boomed, very high accessibility. Now you can go to the store down the street and you can buy a drone that could do way more than military drones could do 20 years ago. So then I sidestepped into the marine robotics industry, and I saw a slightly different picture here. So we also have many cool applications and benefits, of using robotics in the marine industry. It's 10 years later, we've got very, very affordable sensors and processing, very mature open source hardware and software, and the missing piece is that just historically there's been a severe lack of affordable marine robotics components and sensors. Like we ran into, we wanted to build a vehicle, and right out the gate we'd have to be spending thousands of dollars just on motors, and it was just not going to happen, which that sort of situation leads to slow growth, leads to limited accessibility, and limited success for companies and businesses that are growing in this space. So we made it our mission at Blue Robotics to solve that. We thought we could address this issue, create affordable components and sensors, and then create a marine robotics industry boom, the same way it happened in the drone industry. Some of that has happened. We're still working on that. This is a snapshot of some of our product line today. So we have nearly 250 products in our online store with the thrusters still on there, but once people had thrusters, then they started asking for watertight enclosures to keep their electronics dry. So we built a line of watertight enclosures. Once they had those enclosures, they needed sensors. So we made pressure sensors, temperature sensors. They needed something to power their vehicles. So we provided batteries that fit in those enclosures. They needed lights, tethers, communication electronics manipulators. And we just slowly, for the next couple of years after launching that thruster, we slowly built up a product line of enabling components to make it easier for people to get started in marine robotics. And then in 2016, we put together all of those pieces and created the Blue ROV2 vehicle here, which has become one of the most popular remotely operated underwater vehicles on the market. This is still our mission. This is still going to be our mission for the foreseeable future, is to create these components and systems, but focusing on low cost. A big part of our business model is to make these components accessible as well. Before we existed, almost everything in this industry was behind a wall. You had to talk to a salesperson, you had to get a quote, you had to work with them on custom specifications. If you wanted to get started, it was a very long process. So we wanted to make sure that we sold things online. You could order something and it ships out the same day, which is not a revolutionary idea in the world in general, but was a revolutionary idea in the marine robotics industry at the time. All right, so that's, let's see here. And then I just want to share some of the cool applications that we've enabled. There are literally hundreds. This is my favorite part of my job now, is seeing all of the cool things that our customers do, but I'll point out a couple here. Starting up at the top left, this is a high school student who used some of our components and enclosure, some domes, some lights to build a drop camera system that he could drop down to 1,000-meter depth and basically film deep sea life at $1,000 budget, which is something you just could not do before. Very, very cool. I think he did most of his testing in Italy. This is another hobbyist customer who built a surface vessel, put a sonar on it, and surveyed a local lake. Another customer here built this pretty wild contraption. It's this giant claw. This is huge, like could probably pick up a car. It's got thrusters up here at the top so that it can be steered around and moved around to its target, which is really cool. Never would have thought of that application, but they did. This is a student team who built an ROV using all clear acrylic and lots of LEDs. Made a very, very cool vehicle here and inspired hopefully a future generation of marine robotics enthusiasts. Over here is a picture from the Woods Hole Oceanographic Institution where they're using the Blue ROV2 for autonomous systems research. We've got another hobbyist here who managed to rescue his fallen hexacopter from a lake in Alaska. This is one of our customers, Nautilo or iBubble, from who's working on a diver following a selfie drone for divers. So this drone is untethered and follows divers, takes pictures of them along the way. Very, very cool. This is at the Monterey Bay Aquarium Research Institute. They installed one of our ROVs down at 850-meter depth and left it there for a year. They were able to do that because it has a lot of open source interfaces. They were able to change things that they needed to change in order to make that possible. We have a lot of customers who are building surface vessels like this one here. both at the commercial level like this one and at the very hobbyist level like this one here. And then these last two are both very cool. This is a company in Australia called Abyss Solutions, which has outfitted the Blue ROV2 with a host of very high-end sensors. They've got strobe lights here, a lot of cameras, and they're able to do metrology, basically measuring things underwater with extreme accuracy with the ROV. For instance, they can be looking at the chain, an anchor chain being lowered down from a boat, and with those cameras, they're able to measure the dimensions of each link in that chain and tell the owner of the boat whether one of those links is about to break and they're going to lose their anchor. And then last here but not least, one of my favorite applications is this lionfish hunting robot from a company in Florida in the US. This is a lionfish right here. They're an invasive species in the Caribbean. They eat anything. They're destroying a lot of habitats. And so they reconfigured our vehicle here and built this giant lionfish vacuum section in the middle. And they're actually able to like drive this up to a lionfish, electrocute it with 2 metal plates, and then vacuum it into the system, reaching much greater depths than divers can reach, so that they can clear out these invasive species in, with much more effectivity. So just super cool applications. But enough about us. So I'm going to talk a little bit about just kind of hit on some of the elements that go into a concept design and creating a company around that. And I want to start here with vision and strategy. I talked about that a lot in our own background about kind of where our vision came from, what made us realize the niche that our company was to fit into. And then I think one of the most important elements to our success has been sticking with that vision and making sure that we have a clear place in the market. All right, so first of all, let me just lay out how I see these things existing. So up at the top of your thoughts behind creating a company, you're going to have vision and mission. That's why you exist, what you want to achieve, what you're hoping to get out of this. After that, you have your strategy, which is the actual path that you will take to achieve that vision and mission. Has some more details about how you're going to get there. And I'm mostly going to talk about those top two. But after that, you have initiatives, which would be major efforts that you would undertake to achieve our vision and mission. And then objectives, getting more specific, and key results. Just like Eden mentioned, we also use the OKR system, objectives and key results, in our goal tracking. So there's lots of ways to think about this. It's all an abstraction, but it's important to have these things in mind, like the vision and mission and the strategy, when you're coming up with a concept and creating a company. So starting with that vision and mission, you want to talk about why you exist and what you want to achieve. Obviously, for every company, this is going to be very different, so I can't necessarily help you with yours, but I can share what ours is. For us, we enable the field of marine robotics with affordable components and systems. And we do so in such a way that contributes to humanity's need to understand, responsibly utilize, and act as good stewards of the oceans. Then at a more fundamental level, our team has a deep aspiration to build a company that lasts for a long time and leaves a legacy of positivity on all of those it touches. So these 3 sentences here are extremely important for our company, and they define many of our decisions, all the way down to concept development decisions. Just this first sentence here, we enable the field of marine robotics with affordable components and systems, defines a lot of the requirements that go into our products. Like they must be affordable, we must be enabling people, which means we need to make components that are going to be useful to a broad range of people. They must be useful to people who have applications that we haven't even envisioned yet, and help those people out. That's part of our core business model. When we're thinking about a concept from the beginning, we're thinking about this vision and mission. So if you've got an idea, I would encourage you to think about what you want out of a company or vision at the very beginning. Write it down, because it's going to have a big impact on how you end up writing your requirements, what kind of customers you target, and how you go about achieving your goals. So next is a strategy, the path that you take to achieve that vision and mission. There's a lot of ways to think about strategy. For me personally, it took a long time to wrap my head around the difference between having a vision and mission, having strategy, having a plan. And so this strategy here kind of sits in the middle between that vision and mission and a plan. Plan tells you what you're going to do. The strategy tells you how you're going to do it, how you're going to approach it. It should help you make decisions. We've defined this in terms of what we do, who we do it for, and how we do it. So as far as the what, got a very clear statement here. We design, manufacture, and market quality components and systems for marine robotics designed to operate anywhere between the surface to 1,000-meter depth. There's a lot of important things in there. So there's a scope here of what we want to accomplish as a company. Design, manufacture, and market. If we took out this manufacture word right here, it would completely change the scope of our company. Maybe we'd want to work with a contract manufacturer or license our designs, but that's not what fits us, but it's incredibly important to know that from the beginning. And then let's focus on marine robotics. That gives us a lot of scope on what we're working on. And then between the surface to 1,000 meters depth is an important part here. That's the space where we realized we could have the most value to the market. When we started the company, most subsea companies were targeting much greater depths, like 6,000 meters, or just at the surface. You could find things that were rated for 1 meter depth or 6,000 meter depth, but nothing in the middle. And that's where we saw that we could reduce the cost, reduce the barrier of entry to people, and service the vast majority of customers' needs. So we focus very clearly on that range. As far as the who, we made a decision that we appeal most to technically inclined, enterprising people who have an interest in the ocean, and we provide distinct value to those people. There's a lot of important stuff in here as well. So technically inclined means that we expect our customers to have a pretty strong technical knowledge, which means that they can, like, we sell a lot of our products as kits or individual components, and we expect those customers to be able to understand that and put them together. Most of our customers are engineers or entrepreneurs who are enterprising people starting businesses, and we've made an explicit decision to focus on this customer base. As an alternative, we could decide to focus on consumer type customers, and that completely changes the way we would approach our product. Then they have to be much easier to use. They probably have to be lower cost. Our manufacturing would be targeted to build larger volumes at lower margins. There's huge ramifications to who you choose to sell your products to. And then last, the how, and I'll explain this one a little bit more in the next few slides. The how for us is that we will operate in blue ocean markets where we can have distinct and uncontested value to our customers. And so I'm going to talk about that blue ocean strategy concept here. So this is something we've done from the beginning, something I think is one of the most important elements of our success. And I want to share that. There's a book called Blue Ocean Strategy, which I would highly recommend. I wish I had read it much earlier, but it's had a big impact on how we approach designing new products and our existing products. So let me explain this concept. A blue ocean market is a space in the market where there is no competition, but a strong need. And as an example, we've tried to have this approach since the beginning. So our original T100 thruster entered a blue ocean market. And if you remember, I said there were products that were, $1,000 or more. And then we also found hobbyists who were tearing apart like bilge pump motors from boats and turning those into thrusters, and they could do that for $10 or $20. So there's just two extremes, nothing in the middle, nothing satisfying a fairly large group of customers who are looking for this product. That's a blue ocean market right there. Like, there's nobody competing in that space. We created new market. We're not stealing, not necessarily stealing from the people selling thrusters for $1,000, or replacing people who want to do it for $10, but creating new market, and which people can then, they can use our thrusters to do new ideas, build a new company, create a new concept. And I think the important thing here is that companies and people in general regularly do the exact opposite of this. people look for who they can compete with. You know, you look at the guy over there who looks like he's being successful, and you say, well, he's being successful. I bet we can take what he's doing and make a slight tweak to it, or make it slightly better, and you know, that will be our company. And in my opinion, that's the opposite way that you want to be thinking about it when creating a concept or a company. You want to find the hole in the market where you're not going to have any competition at all. You're not going to be competing with anybody else, but there's customers looking for that. So we're, as a company, we're always searching for blue ocean markets, and we specifically design our products to fit in those markets in terms of price, capability, and design, so that we're not trying to compete with anybody else. We're just in our own space. And fortunately, if you read this book, Blue Ocean Strategy, there's some tools to help you do that. I'm going to show you one of those, which I think is really cool. This is called a Blue Ocean Value Curve, which essentially shows compares two offerings, two products. So we've got like the average product in a certain industry here. Let's say this is an ROV, a remotely operated underwater vehicle. So you've got some features like depth rating and cost, and those are either high or low. So maybe you have a high depth rating and a high cost, and you know, low user friendliness. It's all these things that could contribute to this value curve. Oops. And then what you want to have as a company when you're creating a new concept is to have a value curve that is different than your competition, different than the rest of the market. And so this is an example here. I know there's no labels on what these points are, but I'll show you a more specific example in a few slides. So whether you offer high or low features on your product, maybe you have low cost, high performance, but you sacrifice something else in order to get that, you're creating a product that fits into the market differently than everything else. If you create a product that just follows the same curve, you're probably going to have a lot of competition, and it's going to be hard to be successful. But if you can find a curve that is valuable to people, that breaks out of that mold, then you will have a good blue ocean product. So I know that doesn't make a whole lot of sense yet, but I'm going to explain that in a few slides through an example. So let's talk about a product that we developed a couple years ago. That's called our Ping Echosounder, and I'm going to talk about the kind of the thoughts that went into that from the very beginning. So we were looking at the market. We saw a need for an echosounder for altimetry, obstacle avoidance, and basic bathymetry, measuring the depth of water. And we wanted some on our RV. We wanted something with about 30-meter range. We wanted it to be pressure rated to 100 meters would be fine for us, and we wanted it to be compact. And so we started looking. We looked at the options on the market. There are a bunch of companies that make echosounders. It's one of the most popular sonar products to make. So there are just tons of options. And what we found is that all of those products are in the $1,600 to $4,000 US range. This is 4 or 5 years ago, which was just crazy to us. You know, this is the size of just a tiny little device, very, very simple function. And there's the ones that you could use underwater for marine robotics are $1,600 to $4,000. Almost all of them were rated to 1,000 to 3,000 meter depth. They usually had a range of at least 50 to 100 meters. And so we realized that there is a hole in the market for a low cost product. And we can make the sacrifice of having a lower range and a lower depth rating, which will keep us in a blue ocean market. Most of our customers don't need 50-meter range. They don't need 1,000-meter depth rating. So if we can make it less expensive within those specifications, we could be very successful. We looked at some examples that were outside the marine robotics industry. So this is an ultrasonic rangefinder you might find on a drone. This one is $25, using very similar technology as a sonar. And then we also found this product on Amazon for $85. It's this little fishing bobber. You attach to your fishing line, cast your fishing line out, pull up your cell phone, and it gives you a Bluetooth connected fish finder view and shows you fish underneath. A fish finder is essentially an echo sounder. So obviously somebody here is able to do what we want for $85 and get 40-meter range. So we knew it was possible to achieve this well within our price range. So we pursued that, ended up building this device here. We actually took a lot of inspiration from that fish finder. The acoustic drive circuit is modeled after the one in that device. So our product has 30-meter range, 30-degree beam width, 300-meter depth rating, an open communications interface, which is very, very important for robotics and separated us from like that $85 fishing bobber, which doesn't have any sort of open source interface. And we were able to make it for a price of $279 US dollars, which is a lot more affordable than anything else on the market. So having a product like that enables altimetry and range finding on low-cost ROVs, enables cost reduction of AUVs, high volume remote sensing, and most importantly, big question mark there is just whatever our customers want to do with it. Probably the coolest applications for a device like this are things that we never would have thought of during the requirements or concept development phase, but we tried to leave the design open to enable that. And then I'll show you the value curve for this product compared to those other products on the market. So I've got each of the value propositions that marine robotics sonars tend to offer. And so we've got price, range, a compact size, a depth rating, and available software libraries. And so the average device on the market was very expensive, very high price, high range, not that compact in size, but really high depth rating, and not that good of software libraries available, which made it hard to get started with. Our product, on the other hand, has low price, but also low range, very compact size, a lower depth rating, but very high accessibility in terms of software libraries. We have Arduino libraries and Python libraries, and try to make it very easy for our customers to get started. So by creating this product here that fits in a very different value curve than the other products in the market, we've created distinct value. We're not necessarily competing with the other sonars that are out there. We're fitting in a space that previously did not exist. And we try to do that with every new product. Okay, I'm gonna check real fast, make sure you guys are still here and I'm not talking to an empty room. And if there's any questions, okay. All right, so I've got a couple more slides here. I'm not going to go into a huge amount of detail about this, but I just want to chat about it. Then we'll be open for questions. So you might be thinking about the product development process and what that should look like. And for us, this has changed dramatically over time, and I think that's totally fine. If you read a textbook about product development, they're going to give you a lot of ideas about how it should be, but it has to fit with your company at the time that you're at. For us, it started as a very casual process. You know, the original thruster was just myself, with very little testing, very little prototyping, very small budget, and all of our initial products were very, very casual product development. Walk up to an engineer, talk about an idea. The next day we'd have a CAD model and start working on it. Very little structure. As we've grown as a company, it's become a more structured process, which is important, mostly for communication and making sure there's consensus between everybody. But how you do this is definitely going to depend on where you're at as a company. And I think, personally, I think it is okay to create the minimum viable product at the beginning of your company's history. If I hadn't done that, if I'd tried to create the perfect product from the beginning, I never would have started the company, never would have launched anything, never would have grown, and I wouldn't be sitting here today. So I had to start somewhere and then had to improve from there. And everybody should feel free to do the same, I think. This is part of our product development process in the validation testing section. This is an ROV. This is actually just from a couple of days ago of an ROV being tossed over the side during a test. All right, so I'll breeze through some of these. We start with a concept design phase now. And there's a few important documents that happen in there. We start with a project charter, which is a document to define the project needs and requirements, and most importantly, is to build consensus between everyone involved. This might not be necessary if you have 2 people in your company, but once you have 50 people, there's a lot of people involved, and they all need to be on the same page. So you need a document that centralizes that. We have a market strategy as well, which defines our plan to approach the market with this product. How's it going to fit into the blue ocean market? How will we promote it, etc. There's 1,000 questions you can ask. What the price is going to be, how many we're going to sell. We do design research and iteration, which is just early work on the concept design to show that it's feasible and to help us figure out the requirements if we're not that familiar with the product yet. And then last, we do user research, usually interviewing users, talking to some of our customers. This could even just be casual conversations at trade shows that give us an idea of what those customers are actually looking for and what would satisfy their needs. From there, provided everybody agrees to us moving forward with this project, we go on to a prototype development phase where we continue the design iteration and testing. We usually have a better idea about how we're going to approach the final product at that point. And then we start getting into more detail. We do failure mode and effect analysis, meaning we reduce the risk of the design by studying potential failure modes and making sure that the important ones are addressed early in the design process. We also do failure mode discovery testing, which is to push the design to its limits and to learn where and how it fails so that that's not unexpected later. We do human factors testing by having representative users try the product to make sure that they have a good experience. Create a final prototype model and drawings. So this is obviously at the end of the prototype development phase, and then prepare for validation testing. And the actual production process as well, if it's a product that we're manufacturing. All right, then in the validation phase, this is where we prove out that the product is as good as we think it is and that it is a reliable product. So we design tests, we select a sample size, we order parts, we practice the manufacturing process until we get to a validation build where we create a batch of units to the final specifications from our manufacturing team, and those are the units that we do our validation testing on. We do lab validation, a series of lab tests to show that the product meets requirements. Usually there's more samples in the lab validation because it goes faster and you can test very specific things, but it's also important to do field validation to show how the product works out in the field, because you're always going to run into things that you didn't expect in the field or that you can't recreate in the lab. From there, we update our failure mode and effect analysis based on any new failure modes or changes to failure modes that we determined during that validation testing. We determine a reliability for the product, and then we're moving on. Here's a quick snapshot from some of our recent validation testing of a new product over here. This is one of our key pieces of equipment for that. This is a pressure chamber that can cycle these 2 tanks to 1,000-meter depth. And one of the coolest things here is that this tank has a refrigeration unit and this one has a heating unit, so that we can simulate pressure, electrical current, and high and low temperatures all at the same time, which pushes our products to the limit, but is really important. We've got customers in Norway who are using products in very cold water, customers in Hawaii who are using it in hot water. Sometimes it sits out in the sun or is in freezing temperatures during transportation. That's all very hard to recreate, but can lead to a lot of problems if we don't test for it. Here's a couple field validation ROVs recently. Probably one of these was the one getting tossed into the water. All right, I'll move forward quickly here since we're kind of moving past the concept phase here, more towards manufacturing and launch, and I won't focus on that as much. So at this point, we often do beta testing where we have early users test and give us feedback. It's really hard to get feedback from them sometimes, so we try to do as much of the testing ourselves as possible. We go into manufacturing readiness. Kind of going into all of this is probably outside the scope of this conversation, but I think the important part here for somebody developing a concept is that figuring out the manufacturing here takes a long time. I think often it's about halfway through the overall development process where we have a finished prototype, and it's the other half where we're figuring out manufacturing and how to build that product at scale reliably, that it's validated, and that we can recreate it over and over and over again without any problems. So this is definitely not something to underestimate. I definitely did at the beginning. I thought once the design was done, we'll just manufacture it, it'll be easy. It's not the case. And then hopefully you eventually get to the launch phase where you're doing the exciting part. You're marketing and selling the product, you're announcing it, going to trade shows, talking to customers. This is the fun part. And hopefully you've got lots of inventory on the shelf, ready to go out the door to your customers when that happens. So let's see here. That is all I have prepared for today. I just pointed out some of the highlights of things that we think about during the concept development process. But I'd be happy to answer any questions about anything I talked about, or there's obviously a lot of other things that I would be happy to chat about if you want to go off topic.
Thank you. Thank you for your interesting presentation. I'll open the floor for questions. Please don't be shy. I know that it's late for us, but I think Rustom had some interesting points that I'll follow up if no one asks these questions, but I'd like first to hear from my colleagues. Just unmute yourself if you wish. Okay, I'll start with, okay, yeah, please, Adam.
Hi. Thank you for the presentation. So what I'm interested in is what regarding the manufacturing. So what are the stuff you are outsourcing and what are you trying to do in-house? So what are the key partners you have this in the manufacturing chain?
Yeah, I think ours sounds somewhat similar to yours, where we have all of the hard manufacturing like injection molding, machining, cable assemblies, PCB assemblies. That's all done outside of our facility. A lot of it's done in China to keep the costs low. A lot of it's done in the US. And then we do the final assembly of the product in our own facility. So we take those raw components and we're usually just using hand tools to assemble it. And so that gives us access to very low prices by using overseas suppliers for individual components, but it also gives us a lot of control over the final product and integration, a lot of agility to change things on the fly if necessary, if there's problems. You know, we don't have to fly to China and teach people how to build the thrusters differently. We can walk down to the production line and change it right now. So I'm happy with that approach, but there are lots of different ways to do that depending on what you want as a company. We're mostly a manufacturing company now, which is not what I thought I was creating when I started this company. But that's by the nature of our products, we have to manufacture them to get them out the door, so we've become a manufacturing company.
Cool. Yeah, I saw some figures where you have a bunch of cables, and you know, in robotics, especially in our products, there is a lot of cables, and like manufacturing cable was a mess for us, and like one critical milestone for us was to outsource the cabling. And I don't know what's your approach to cables. Do you do this in-house or outsource?
Yeah, we outsource it. It's not a fun one to do yourself.
Cool. Thanks.
Yeah, of course.
Thank you.
Thanks for your presentation as well.
Other questions from the audience? Well, I have a couple of points that I noted. Well, I'd like to ask you to comment quickly on the crowdsourcing and why not, maybe. That was an interesting point.
Yeah.
And also, I'd like to let you know that a company in Croatia, they are external partner of this project. They're not in the project, but they are a partner of some of us, are actually doing electric surfboard now for recreation purposes, not like a wave ladder, but just surfboard for people to play around.
Yeah.
And the other interesting point that you mentioned was that in the beginning, it was very important for you to choose your customer. So how much of that affected your design choices?
Okay, well, let me start with the crowdsourcing. So we did a Kickstarter campaign, and there were a lot of very good things about that. We built an incredible network of customers. It was a great way to market our product initially because we had that platform to go off of. The thing that I don't like about it is that as somebody starting a company, you at that point in your history, you want to be very successful. So you don't have a product, you don't necessarily have a complete product yet, so you don't know exactly how much it's going to cost or how much effort it's going to take. And so you tend to price the product as low as possible, sell as many as possible without knowing what it's actually going to take. So it's a very high risk combination of factors. If I were to do it again, I would want to start much slower. You know, instead of selling 600 before we'd ever built the first one, I'd want to start selling 1, 2, 3 at a time, get some feedback from our customers, and actually be able to incorporate that. I'd like to not have the timeline pressure that came with the Kickstarter, because you tend to give a very aggressive timeline because you're trying to satisfy these customers and have a very successful crowdfunding campaign, which almost always ends up being unrealistic. So there's definitely a time and place for it, but I don't think I would do it again now. And then it's cool that there's a Croatian company doing a surfboard. I'd like to see that. And in terms of when you choose your customers and then how that affects your concept design, I think it has a profound impact on how you approach your design. Let's go to this Croatian surfboard company. So assuming you're targeting recreational surfers, you know, you need something that's very easy to use. Like, you want it to be very, very, very attractive. You're probably going to put, like, surfers care a lot about how cool their surfboards look. So you're going to put a lot of effort into making sure it looks cool. Maybe you want to hire an industrial designer and focus on that element more of it than the performance. Versus if you're building that same propulsion product for the marine robotics world, probably care a little bit less about how it looks. It can probably be a little bit more expensive. It can be more, but maybe more flexible for use in different types of vehicles. And so that decision up at the beginning has just a massive impact. So I think
it probably explains a lot your success, right? Because you chose the right target.
Yeah, we chose a target that nobody else was targeting, which is important.
Yeah. There is a comment on the chat from Matteo, he's the project manager, about that this is a very interesting approach to development of product and company. I don't know, Matteo, if you want to make some question or comments directly, you can unmute yourself. If not, we have also a question from Andreas, please.
Yeah. Hi, do you hear me?
Yeah. Hey, Andreas. Yeah.
Don't fight. I know that you both sell robots, so please don't fight.
No, we're friends, don't
Marine robots, even.
Yeah, definitely. And I really like your presentation in terms of knowing the market and the differences between making products towards like, is the end customer an engineer who knows how to build stuff, or is it man on the street who doesn't really know anything about robotics? And I think that's also where we are kind of different, and that's a different kind of approach to the market.
Yeah.
And of course we are really happy with your thrusters, which is also in our vehicles, and we have used thousands of them, and they have close to 0 failure rate, so that's really good.
Cool.
Yeah, but I was just wondering, do you have like any when you design a new product, how do you kind of decide if it's good enough to ship, or does it need more testing, and have you ever like shipped too early or anything like that?
Yeah, that's a really good question. So that, I think, like the product development process, that changes over time as your company changes. So when we started, our customers were mostly students and hobbyists, and their expectations for us were pretty low. You know, we were just that company that they backed on Kickstarter. The stuff was 10 times cheaper than anything else, so like maybe it will work, but probably not. Yeah. And so obviously their expectations were low, and so we blew those expectations out of the water. But now we're 7 years later, and now those same people who were students and hobbyists, now like they've started companies, they're like doing research, they're like operating for 8 hours a day using our products, and their livelihoods depend on our products. So now the stakes are much, much higher, and what we deliver has to be much higher. It means our new products also have to be built up to that new standard rather than our original standard, because that's what our customers need and expect now. So it's changed a lot. We've definitely launched products too early multiple times. Haven't always learned from our mistakes, but as long as you take care of your customers in that situation, replace the problems, be very understanding, they tend to be very happy about it. But yeah, it's tough. In the last year, we've hired, we've added that we didn't have much of a validation process, and now we have a reliability engineer who has a background in doing high volume testing. On our most recent product, I showed that picture of testing. We literally tested 1,000 units through intense testing and have a very sophisticated reliability model before we launch the product, which is never something we would have done 5 years ago. It would have been totally infeasible.
Totally makes sense. And of course, that's also a part of it. You have to bootstrap in the beginning and make something good enough, and to get going, you kind of just have to keep momentum, and then you can. It's also important to step back a couple steps and redo and make sure that the quality is not lacking as you grow.
Absolutely. That's one of the things I'm happiest with, is that we started with individual components. And so we were able to start the company with very small upfront investment compared to, you guys are a good example. You developed an entire vehicle from the ground up, and you had to finish that vehicle in its entirety before you could ship anything. Yes. And that's extremely difficult to do. We took the easy path, and we made one component at a time and started selling those individually until we had enough components to build a vehicle.
Yes.
Which was, that was the only, didn't have enough money to invest into a big development, so that was the only way to do it.
No, it's cool how it's you have a really brick by brick strategy, kind of building as you go. So that's a good strategy.
Yeah, every company will be different.
Mm-hmm.
Yeah, that's why I try to invite people from different companies with different stories, and backgrounds, because it's very interesting to also see the different possibilities and compare how companies actually evolve, just not to have one different view. Yeah. I see a question from Francesca. Unless, Andreas, do you have other questions? No.
No, just carry on. Thanks.
Okay, Francesca, please.
Hi, everyone, and thank you very much for the very interesting presentation. I'm from Marine Science Institute, so we are dealing with the science, let's say, connected with the marine issues. And this is very interesting because we can see, let's say, that from the technological perspective, the thinking process to build this kind of the sensors and the vehicles that we are going to use to make our science. So thank you very much, and this is very interesting for us. And I have a question in terms of how much you think this kind of, at least in Europe, we have this kind of incubators and let's say digital innovation hub where we are trying to connect different companies, and InnovaMare, this project is focused on this kind of activity. And how much you think this kind of things, this is a question for all the speakers, let's say. I don't want to take much time, but just to know how much you think this kind of tools, let's say, can help the process of building the new products and so on. So, and if you have, let's say, suggestions on which functionalities and which kind of things can help you in the building this kind of things. Thank you. I mute my mic because I have the baby screaming. So sorry.
Yeah, I can start off. So thanks, Francesca. I think to me the most important thing is that it's really hard. It's hard to learn how to do this from the beginning. It's most of the times it's not something you learn in school. So you can only learn from people around you and other companies. And so just getting exposed to other people who are working on concepts is extremely valuable. And you know, having a place to be around them and access to shared resources is definitely valuable. We use some of those sorts of resources at the beginning, and as we grew and became more mature, we've used less of that, but I definitely support it. I don't know if you have anything to add, Andreas or Eden.
Edwin or Andre? Yeah, Andreas, then Edwin.
Yeah, of course, it's in Norway we have these national funding entities or things that you can apply for, which are important for new concepts and innovation projects. So that's one area that's good for new companies to kind of apply for an idea and get funding to get going in terms of, and also you have the tax. It's called SkatteFUNN, which is like you get the tax back if you do research in or new development in technology areas. So both those possibilities has been important for us. But I also think it's important that when you get exposed to robotics and underwater robots, etc., at the university, it's also important that it's easy to get started. So I remember when I did my project thesis on the Blue ROV, actually, the first kit.
Cool.
We spent like most of the project thesis just to build the robot and to create the software to be able to run it with ROS. But now I see that when we engage new master students with our Blue Eye and the SDK, then you can get started much faster because the hardware is completed and you can just jump right on the theoretical task or doing your biology research or taking images of algae, whatever. Do more of the research part rather than just building vehicles. So I think it's good for different purposes. If you want to build something, a new vehicle and a new platform, it's good to have the supplier of components. And if you want to do more control system design or software development, it's probably better to have a system that's like a stable platform that you can start off with.
Yeah, I can also say a few words. So yeah, I think. Yeah. Can you hear me? I think I still have a problem.
Yeah, I can hear you.
Okay,
Yes.
so yeah, I think any activities that supports like building the ecosystem of knowledge, tools, and people are great. I think in Croatia, such as incubators, I think in Croatia there is it has started like a few years ago. There was a little ability to get access to knowledge, people who know something about tools, like in maybe other countries, but I'm seeing traces of improvement there, which is great, and I think supporting this is really important for the next generation. Like, so I encourage that.
Thank you. Thank you all. Any final question? I don't want to interrupt the people from asking, but I also understand that it's late and we are very thankful to all the speakers for being here. But if there's one final question, I'll allow it. If not, we'll need to. Okay. No? Well, then I'd like to thank you again, all the speakers. It was very interesting to hear all the presentations, different things happening and different approaches. So it will give us a lot to think about and choose our own approach on the development of our robots and sensors. It was a pleasure to have you here. Unfortunately, we couldn't meet all in person, but I hope that we'll be able to meet all in Croatia sometime in the future. And I will follow up with you if there's any further questions from the audience or any other engagement opportunities. Thanks again to the three of you, and thanks to all the attendees. If you want to say some final words to say goodbye, each of the speakers, please.